हे लॉन्ग आन्सर क्वेश्चनचे आन्सर की आहे. फर्स्ट क्वेश्चन, एक्सप्लेन द फॉर्म्युलेशन्स ऑफ स्टेशनरी वेव्ह बाय द ॲनालिटिकल मेथड. हॅलो फ्रेंड्स, कसे आहात? आज आपण महाराष्ट्र शासनाने शालेय शिक्षण व क्रीडा विभागाने जी 2023मध्ये क्वेश्चन बँक पाठवली ती फिजिक्सच्या विषयाची एंटायर सिलेबसवरती, त्याच्यावर आपण आन्सर की बघणार आहोत. चला तर मग त्या क्वेश्चनकडे आधी जाऊयात. आहेत लॉंग आन्सर क्वेश्चन. आज आपण लॉंग आन्सर क्वेश्चन बघणार आहोत. एकूण 6 आहेत. याची आन्सर आपण पुढील प्रमाणे PDF स्वरूपात पाहूयात. हे लॉंग आन्सर क्वेश्चनचे आन्सर की आहे. फर्स्ट क्वेश्चन, एक्सप्लेन द फॉर्म्युलेशन्स ऑफ स्टेशनरी वेव्ह बाय द ॲनालिटिकल मेथड. What are nodes and antinodes? Show that the distance between two successive nodes or antinode is y lambda by 2. Answer, expression for equation of stationary wave of an stretched string. First, consider two simple harmonic progressive wave of equal amplitude A and wavelength lambda propagations on a long uniform string in opposite direction. Second, equation of wave traveling along the x-axis is positive direction is given by y1 is equal to a sin into bracket 2 pi under root nt minus x by lambda bracket complete curly bracket complete. The equation of wave travel along the x-axis is the negative direction is given by y2 is equal to a sin into bracket 2 pi into bracket nt plus x by lambda bracket complete. Third, when this wave interference of the resultant displacement of particle of the string is given by principle of superpositions of waves, y is equal to y1 plus y2. Therefore, y is equal to a sin into bracket 2 pi under root nt minus x by lambda plus a sin into bracket 2 pi nt plus x by lambda. Fourth, by using the trigonometric formula sin c plus sin d is equal to 2 sin into bracket c plus d divided by 2 into cos c minus d divided by 2. Therefore, y is equal to 2a sin into bracket 2 pi nt cos 2 pi x divided by lambda. Y is equal to 2a cos into 2 pi x divided by lambda sin into bracket 2 pi nt. Equation first. Fourth, substituting 2a cos into 2 pi x divided by lambda is equal to a in equation first. Y is equal to a sin into bracket 2 pi and t. Therefore, y is equal to a sin omega t. Therefore, omega is equal to 2 pi n. This is the equation of stationary wave which gives resultant displacement due to simple harmonic progressive waves. 6 nodes at the point of a medium which vibrate with minimum amplitude are called nodes. A condition for nodes amplitude in minimum, that is a is equal to 0. Therefore, 2a cos 2 pi x divided by lambda is equal to 0. Therefore, cos 2 pi x divided by lambda is equal to 0. Therefore, 2 pi x divided by lambda is equal to pi by 2, 3 pi by 2, 5 pi by 2. Therefore, x is equal to lambda by 4. There 3 pi by 4, 5 pi by 4. That is, x is equal to 2p minus 1 lambda by 4, where p is 1, 2, 3. Distance between two successive nodes, 3 lambda by 4 minus lambda by 4 is equal to lambda by 2. 5 lambda by 4 minus 3 lambda by 4 is equal to lambda by 2. Therefore, distance between two successive nodes is lambda by 2. Seventh, antinodes. The points of medium which vibrate with the maximum amplitude are called antinode. Condition for antinodes amplitude in maximum, that is a is equal to plus minus 2a. Therefore 2a cos 2 pi x divided by lambda is equal to 2 plus minus 2a. Therefore, cos 2 pi x divided by lambda is equal to plus minus 1. Therefore, 2 pi x divided by lambda is equal to 0 pi, 2 pi, 3 pi, dot. Therefore, x is equal to 0, lambda by 2, lambda 3 lambda by 2. And that is, x is equal to lambda p divided by 2, where p is equal to 0, 1, 2, 3. And therefore, distance between two successive antinodes, lambda by 2 minus 0 is equal to lambda by 2, y lambda by lambda minus lambda by 2 is equal to lambda by 2. Therefore, distance between two successive antinodes is lambda by 2. First question apply. Second question number second. Explain the production of beats. Deduce analytical the expression of for beats frequency. Answer. Production of beats. A. When there is a superposition of two sound waves having same amplitude but the slightly different frequencies traveling in the same phenomena, same direction, the instantly of the sound varies periodically with the time. Thus, the phenomena is known as production of beat. B. The variation in the loudness of sound that goes up and down is the phenomenon of formation of beat. See, it can be considered the superpositions of waves and formation of standing waves in time at one point in space where waves of slightly different frequency are passing. The two waves are in and out of phase, giving the construction of destruction interference. Second, expression for beat frequency. A. Consider two sound waves having same amplitude, slightly different frequency N1 and N2. B. Let X be the point of the medium where they arrive the phase. C. The distance due to each wave at any instant of time at that point is given as lambda 1 is y1 is equal to a sin into bracket 2 pi into bracket n1 t minus x divided by lambda 1. Y2 is equal to a sin into bracket 2 pi and 2 into bracket and 2 t minus x by lambda by 2 lambda 2. Let us assume the simplicity that is listener is at x is equal to 0. Therefore, y is equal to a sin into bracket 2 pi and 1 t and y2 is equal to a sin 2 pi and 2 t. According to the principle of superpositions of waves, y is equal to y1 plus y2. Therefore, y is equal to a sin into bracket 2 pi and 1 t plus a sin 2 pi and 2 t. Therefore, y is equal to 2a sin into bracket 2 pi under bracket n1 minus n1 plus n2 divided by 2 into t into cos 2 pi n1 minus n2 divided by 2 into t. By using formula sin c plus sin d is equal to 2 sin into bracket c plus d divided by 2 cos c minus d divided by 2. Rearranging the above equation, we get y is equal to 2a cos into bracket 2 pi n1 minus n2 divided by 2 into t into sin into bracket 2 pi n1 plus n2 divided by 2 into t. Bracket complete. F. Let 2a cos into bracket 2 pi under bracket n1 minus n2 divided by 2 into t is equal to a. N1 plus N2 divided by 2 is equal to N. Therefore, y is equal to a sin into bracket 2 pi n t. This is the equation of progressive waves having the frequency n and the amplitude a. The frequency n is the mean of the frequency n1 and n2 of arriving waves, while the amplitude varies periodically with time. G. The intensity of sound is proportional to the square of the amplitude. Hence, the resultant intensity will be maximum when the amplitude is maximum. H. For maximum amplitude waxing, a is equal to 2 plus minus 2a. Therefore, 2a cos into bracket 2 pi n1 minus n2 divided by 2 into bracket into t is equal to plus minus 2a. Therefore, cos into bracket 2 pi into bracket n1 minus n2 bracket complete divided by 2 into bracket t is equal to plus minus a. That is into bracket 2 pi into bracket n1 minus n2 divided by 2 into t into bracket complete is equal to 0, pi, 2 pi, 3 pi dot dot dot. Therefore, t is equal to 0, 1 upon n1 minus n2, 2 upon n1 minus n2, 3 upon n1 minus n2 dot dot dot. This is the time interval between two successive maxima of sound is always 1 upon n minus n2. Hence, the periodic of beat is T is equal to 1 upon N1 minus N2. The number of waxing hertz per second is the reciprocal of period of waxing. Therefore, beat frequency in waxing N is equal to N1 minus N2. First, the intensity of the sound will be maximum when the amplitude is 0 waning. For maximum amplitude A is equal to 0. Therefore, 2A cos into bracket 2 pi under root n into bracket n1 minus n2 divided by 2 bracket complete into t into bracket is equal to 0. Therefore, cos into bracket 2 pi into bracket n1 minus n2 divided by 2 into bracket t is equal to 0. Therefore, 2 pi into bracket n1 minus n2 divided by 2 bracket complete into t bracket complete is equal to pi by 2, 3 pi by 2, 5 pi by 2 dot dot dot. Therefore, t is equal to 1 upon 2 into bracket n minus n2, 3 2 into bracket n minus n2, 5 divided by 2 into bracket n minus n2. Therefore, time interval between two successive minima is also 1 upon into bracket n1 minus n2. The number of waning hertz per second is reciprocal of a period of waning. Period of bt is equal to 1 upon n1 minus n2. Beat frequency is waning, n is equal to n1 minus n2. Question number 3. State and verify the law of vibration string using the sonometer. Answer first. Law of length. The fundamental frequency of vibration of a string is inversely proportional to length of the vibrating string if the tension and mass per unit length are constant. Therefore, n is directly proportional to 1 upon L if T and M are constant. Verification of first law. A, by measuring length of wire and it is mass, the mass per unit length m of wire is determined, then the wire stretch on the sonometer and the hanger is suspended from the free end. B, a suitable tension T is applied to the wire by placing slotted weight on the hanger. C, the length of wire L1 vibrating with the same frequency N1 as that of the tuning fork determined as follow. D, a light paper rider is placed on wire midway between the bridge. The tuning fork is set into vibration by striking on a rubber pad. E, the steam of tuning fork is held the constant with the sonometer box by changing distance between the bright without disturbing paper rider. Frequency of vibrations of wire is changed. F, when the frequency of vibration of wire becomes exactly equal to the frequency of tuning force, the wire vibrate with the maximum amplitude and the paper rider is thrown off. G, in this way, said tuning fork having different frequency N1, N2, and N3 are used and corresponding vibrating length of the wire noted as L1, L2, L3 dot dot by keeping the tension constant T. H, it is observed that N1 L1 is equal to N2 L2 is equal to N3 L3 is equal to dot 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 is equal to constant for constant value of the tension T and mass per unit length M. Therefore, NL is equal to constant, that is N is directly proportional to 1 upon L if the T and M are constant. Thus, the first law of vibration string verified by using a sonometer. Second law of tension. The fundamental frequency of vibration of string is directly proportional to square root of tension if vibrating length and mass per unit length are constant. Therefore, n is directly proportional to under root t if L and M are constant. Verification of second law. A, the vibrating length L of given wire of mass per unit length M is kept constant for verification of second law. B, by changing the tension, the same length is made to vibrate in unison with the different tuning fork of various frequency. C, if tension T1, T2, T3 corresponds of frequency N1, N2, N3, etc. The observed that N1 divided by under root T1 is equal to N2 under root T2 and 3 under root t3 is equal to dot 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 constant. Therefore n under root t is equal to constant. Therefore n is directly proportional to under root t if L and M are constant. Thus the law of tension of vibrating string is verified by using sonometer. Third, law of linear density. The fundamental frequency of vibration of the string is inversely proportional to square root of the mass per unit length linear density into bracket if the tension and vibration length of the string are constant. Therefore n is directly proportional to 1 upon m, that is L and T are constant. Verification of third law. For a verification of third law of vibrating string, two wires having the different masses per unit length m1 and m2 into bracket linear densities are used. B. The first wire is subjected suitable tension and made to vibrate in unison with given tuning fork. C. The vibrating length is noted as L1 using the same fork. The second wire is made vibrate under the same tension and the vibrating length L2 is determined. D. Thus the frequency of vibration of the two wires kept same under same amplitude tension T. It is found that L1 under root M1 is equal to L2 under root M2. L under root M are is equal to constant E. But by the first law of vibrating string, N is directly proportional to 1 upon L. Therefore, N is directly proportional to 1 upon under root M if T and R are constant. Thus, the third law of vibrating string is verified by using a sonometer. Question number 4, numerical. Wave produced by two vibration in medium have wavelength 2 meter and 2.1 meter respectively. When the sound together the produce 8 beats per second. Calculate the velocity of frequency of the vibration. Solution given lambda 1 is equal to 2m and lambda 2 is equal to 2.1 and 1 is equal to minus and 2 is equal to 8. To find I wave velocity v, second frequency n minus n1 and n2, formula v is equal to n into lambda. Calculation from formula v is equal to n1 and lambda 1 is equal to n2 lambda 2, but n1 minus n2 is equal to 8 given. Therefore v by lambda 1 is minus v by lambda 2 is equal to 8. Therefore v under into bracket 1 upon 2 1 half minus 1 upon 2.1 is equal to 8. Therefore v is equal to 8 into 2 into 2.1 divided by 0.1. Therefore v is equal to 336 meter per second, and therefore n1 is equal to v upon lambda 1 is equal to 336 divided by 2 is equal to 168 hertz. Therefore n2 is equal to v divided by lambda 2 is equal to 336 divided by 2.1 is equal to 160 hertz. आन्सर इज वर्ड मध्ये असल्यामुळे त्याला फ्रेम केलेला आहे. आन्सर द वेव वेलॉसिटी इज 336 मीटर पर सेकंड. सेकंड द फ्रिक्वेन्सी आर 16 हर्ड 68 हर्ट्स and 160 hertz. Question number 4. Explain the reflection of transverse waves from the denser medium. Answer. First, reflection of transverse wave from a denser medium. Suppose that the crest of a transverse wave travel along the string and indicate on the surface of a denser medium such as a rigid wall at a point B. As shown in below figure, as crest cannot travel further, it is the reflected since point B is fixed, its displacement is always zero. Therefore, the crest must be reflected in much a way that the displacement at B due to the reflected. Diagram आहे. Change of phase of transverse waves on reflected from a denser medium wave is exactly equal to magnitude and opposite in direction to that due to the incident wave. Therefore, the crest is reflected as a through. Hence, there is a phase change of 180 degree or pi radius when the transverse waves are reflected from a denser medium. Question number 5. Explain the reflection of longitudinal wave from rarer medium. Answer. In this case, the particles of the medium are free or to vibrate. Hence, first, there is no change of phase. Second, a crest is reflected as a crest and through is reflected as through. येथे आपले सर्व लॉंग आन्सर क्वेश्चन सुपरपोजिशन्स ऑफ वेव्हचे संपलेले आहेत. व्हिडिओ आवडला असेल तर लाईक करा, शेअर करा, सबस्क्राईब करा आणि बेल आयकॉन दाबायला विसरू नका, कारण नवीन नवीन अपडेट आपल्या चॅनलवरती तुम्हाला मिळत राहतील. धन्यवाद.